sono in grado solo di ascoltare.
Welcome to the 8th and the last of the ICCG water webinar series on impact of climate change on Alpine Water Resources by Professor Antonio Massarutto. He is Professor of Applied Economics at the University of Udine and Research Fellow at IEFE, Center for Research of Economics and Policy of Energy and the Environment of Bocconi University. His research activity has been dedicated to applied economics analysis of water and waste management. He is author of several international publications in both fields. So today's webinar will focus on Alpine water resources and the impact of climate change. Alps are considered the water towers of Europe, so a significant part of surface and groundwater outflows are directly or indirectly depending on the water accumulated in snow, glacier, or permafrost. So this inestimable function is threatened by climate change. Changing patterns of rain and snowfall and higher summer temperature causing ice melting are expected to generate dramatic change in outflow patterns. And hydropower facilities are intensifying the use of water and affecting downstream flows. Concentration of touristic development in highlands multiplies summer and winter water demand in fragile environments. And also artificial snow production adds further pressures upstream, while irrigated agriculture is pressing downstream. So now we will hear a presentation by Professor Massarutto, and so the floor is yours. Thank you.
Thank you very much. Thank you very much for inviting me. This is the first time I do a seminar in this way, so I hope I'll not get into troubles. Welcome to everyone who is attending from everywhere in the world. So, as anticipated, my presentation will discuss the importance of the Alps for water management and for water availability in Europe. In the second place, we'll discuss how climate change is affecting this fundamental role played by the Alps and by mountain regions more in general. And later on, we'll discuss some economic components of this impact, and we'll discuss some possible adaptation measures and some possible scenarios for the future. So let's start with understanding why are the Alps so important for European water management. In the introduction, it has been said that the Alps are the water towers of Europe. Means that the Alps are a sort of a big big storage system that keeps water stored during winter years and during the periods when it is less needed, and regulates the outflow during the rest of the year, making it more regular and allowing availability of water resources during seasons when normally there would be much less water available than in this case. So the Alps are, in fact, the importance of the Alps does not descend on the fact that the Alps are rich in terms of water. The Alps are indeed very rich in terms of water because there is a lot of precipitation, much more than the European average. But the importance is not depending on that, but rather on the fact that the Alps provide a sort of a natural reservoir regulating summer outflows and so on. Look at this table coming from a recent document by the European Environment Agency. Look at the third and final row. This means that this proportional influence of the Alps means the quantity of extra water on top of how much one would expect, only considering the dimension, the territorial size of the basins, and how much rainfall falls onto them. You see that in the Danube and the Po Basin, for example, this influence is up to 5 times, 6 times more in the Rhone basin is up to 8 times more, etc. So this means that during the summer, in particular, the outflow is regulated by the melting of snow and the melting of ice and so on. This means also that the economic development of the subalpine regions has been dramatically affected, positively of course, by the existence of this resource, in the sense that since water availability is more regular, more easily balanced, more easy to access, this has encouraged the downstream an economic system that is very much water intensive, but also intensive in terms of low technological intensity. This means that water is cheap, water is abundant, and this means that the economy could accustom to using a lot of water with very little economic efforts, with a very little, very uncomplicated management systems, which also helped the economic development of subalpine regions since the Middle Age. Think, as an example, of irrigation in northern Italy, in the Po basin and in the northeast of Italy. Irrigation has started being developed in the early Middle Age, in the 13th and 14th century, and we are still nowadays using the same technical devices that were realized at that time for mobilizing water from the big subalpine lakes like the Lago Maggiore or the Lake Garda or the Lake Como, where water abstracted from there is simply mobilized through gravity channels, gravity systems that mobilize water until it reaches the mouth of the river Po. So this makes fundamentally irrigation in Italy a very cheap resource to access, and this helped to develop a very modern and very productive and a very high value-added agriculture, thanks to the availability of this very cheap local resource. This example shows very well, in my opinion, what is the kind of issues that we have to be ready to discuss about when dealing with water in the Alps. Water in the Alps is not only an important issue because of matching of water demand and water supply within the Alpine region, but mostly on top of that because the Alpine region, as I said, perform this water supply function for the downstream regions, and possible changes in the patterns of Alpine water availability may affect very seriously what happens downstream. In fact, within the Alpine region as such, there are some water problems, but quite reasonably easy to manage. As I said, the Alpine region is very rich in terms of water, much 2 times or more than the European average, and the European average is already large enough. The water exploitation index, that is the ratio between used water and available water, is very low, less than 5%. That is in practice that we have plenty of margins to expand water demand as much as we wish, and this is true at the macro-regional scale. It is probably less true at the sub-regional scale, especially considering that the availability. What is important for us is not the availability of water as such, but rather the availability of usable water whose quality and patterns of availability match the patterns of demand. So this means, for example, that high mountain areas where most of the touristic development is concentrated, the use of resources is more difficult because access to good springs is prohibited during winter, and because good quality resources are not easily available, the more up you go, and so on. And this is an important issue that is perhaps beyond the climate change problem, because the spatial development trends that are mostly driven by touristic demands are concentrating people in the upper reaches of the basins. At the same time, population is is also concentrating in valley floors locations where the main development centers are located. Think of the main metropolitan areas lying within the European territory, which concentrate more and more of economic development and infrastructure and so on. This means that there is an increasing concentration of water uses and also of water pollution in fewer attraction centers, and this may create local problems. But again, this is not mostly due to climate change, but rather to the patterns of spatial development that characterize the European region as a whole. On top of this, water in the Alps fundamentally means hydropower. Hydropower is by large the largest human pressure onto Alpine water resources. This has been particularly true in Italy at the beginning of the last century, since Italy was a country which is rather poor in terms of indigenous fossil fuel resources. So in fact, energy autarky called for a massive development of hydropower, but the same also happened in Switzerland, happened also in Austria and in France, where hydropower is very intensively developed, and this again causes some possible clashes and conflicts between anthropic uses and ecosystem services of other kinds, independently on what climate change generates. But as I said, these problems internal to the Alpine regions are probably only a little part of the total issue, since the Alps are even more important as a source of flows which fuel the downstream uses of energy. So this is just to show the economic importance of hydropower in Italy. This is a study. This is a recent study we made. This is published on the journal Energy Policy. We focused on the province of Sondrio, where the 18% of the total Italian hydropower capacity is located, and we tried to estimate the social economic value of hydropower as the scarcity rent. That is the gap, the difference between the total revenues from selling electricity and the total financial costs of managing and realizing hydropower facilities. The scarcity rent is rather high. In absolute terms, it means between 1.3 and 2.2 billion euros during the period analyzed, which can be translated in a projection at the national scale in close to 1 to 1.5 billion euro per year on average, which this is an enormous economic value. So let's move now to the second issue: what's the likely impact of climate change on all this? Climate change models forecast for the whole of Europe and for the Alps in particular a dramatic increase of temperatures. The forecasts about the Alps are even more severe than for the rest of Europe. The forecasts range between 1.4 and 3.9 centigrade degrees of temperature increase, and the effect of this on the Alps are of two kinds. In the first place, more simply, the increase of the temperature will accelerate the melting of ice stocked in glaciers and in the permafrost. Look at this figure, which is more illustrating than everything else. This is the Pasterze glacier in Austria, at the feet of the Grossglockner, the mountain in the end, in the backstage is the Johannisberg. The blue label represents the point where reached by the glacier in 1975, and you can see with your eyes where the glacier is lying now. The height difference between that blue label and the bottom of the glacier is 150 to 100 meters. I go very often to that place, and this means that a quantity of 200 meters high of ice has melted in the meanwhile, in a little more than 40 years. Okay, this is the first important impact, but the second and even more delicate one in terms of water availability for the subalpine regions concerns the modifications of the outflow patterns. It is not very clear whether on a yearly basis this will mean that there will be less precipitation or more precipitation. Models are not very coherent with this respect. But what is rather sure is that we are going to have much less snow in the winter and less and more rain, which means much higher outflows during the winter, and possibly with an increase of extreme events concerning the floods and so on. While, on the other hand, much less snow means much less snow melting in spring and in summer, and this means that this very capacity of the Alps to operate as a modulation, as a storage system, will be put into question. The snowfall reduction predictions are 40% less in the Northern Alps and even to 70% less in Southern Alps. I hope that the season we are living nowadays in these weeks is not an example of what is going to happen. This is one of the snow poorest winters that I have ever experienced in my life. And as an addicted to ski touring, you can understand how concerned I am because of this. But of course, my ski touring is a minor problem, and a much more important problem is concerned by the frequency and the duration of droughts and dry periods, and the increasing incapability of the Alps to support a regular outflow pattern during the summer. So this is a graph that reprises the same figures. We can proceed with this. Okay, these figures come from ISTAT. The two colored lines concern the two subalpine basins in Italy. The Po is the red one, and the northeastern Alps are the green one. You can see that on a 10 years average, the Po seems to have lost a bit of its average water generation capacity, 12% less. But what is even more interesting to see here is the very high variability from one year to the other. So the changes around the average are more or less 40%, and when we run into a less 40% year, this means that we are going to face a very severe drought. So what kind of scenarios can we expect because of this trend? Again, this is a figure that I borrowed from the same European Environment Agency study I quoted before, and this is very effective in underlying which are the the most likely fields in which the expected hydrological scenarios will possibly affect human consumption and human access to water, and create conflict areas between different users and between anthropic users and ecosystem services more in particular. We do not have time to go in the detail into each of these fields, but it is easy to see that some of these conflicts concern inter-alpine demands, for example, touristic demand versus ecosystem services, or higher pressure on hydropower resources faced to demand for more ecologically sound water morphology in order to maintain good ecological status and so on. But the most severe and the most worrying outcomes are to be expected downstream, since the reduced availability of regular flows from upstream will likely create more pressure and more conflict on water users downstream. My point here is that this is, of course, very bad news for all the water users downstream that have been accustomed to, as I said in the beginning, to use plenty of water with a very low cost, and this means also with the possibility to make overuse or a wasteful use of resources, which is in fact not wasteful in economic terms, because overusing something that is very abundant is not necessarily a bad thing in economic terms. But since the resource is becoming more scarce, it is creating more conflicts. The problem is also that these conflicts are not happening suddenly once forever, but what happens is an increased frequency of conflictual situations, like the one we had to face in 2003 or in 2007 with the two more severe droughts that we have experienced in the time. The example of the Po 2003 drought, however, provides us very useful insights about what can we expect to be in the need of doing in the future. We made a study in the frame of a EU FP7 project about droughts. We have seen, for example, that the costs due to the drought were concentrated in the agricultural sector and possibly in the energy sector, whereas, but for a very contingent reason. So, in fact, we do not expect that these very contingent reasons will repeat. The costs for agriculture were, in fact, mostly shifted on the price of agricultural commodities. This means that consumers, more than farmers, borne the cost of this event. What we also showed is that thanks to the emergency actions that were carried out by the River Basin Authority at the time, by the creation of a negotiated forum with the main stakeholders, they managed to reduce the actual impact of the event to something less than the 50% of what would otherwise be the impact without any kind of remedial policy. But we calculated that there were still margins to improve quite a lot the final outcome by changing something, not necessarily in structural terms through new investment and new irrigation techniques and so on, but just reallocating water, available water, maintaining the same technological approaches to irrigation, just relocating water from the low value added to the high value added crops could have reached even 7 times lower impact in economic terms than it actually happened. So this means that there are very wide margins for improving things without spending too much, just making the management of resources more rational, perhaps moving, upscaling the governance scale and using a river basin approach by introducing more frameworks for inter-stakeholder negotiation and public participation and so on. So what we experienced in this case is that even if the frequency of such events would become much higher than in the past, then we have still a lot of margins to ameliorate things. And the same happens for the water management systems like aqueducts and so on. When I talk of low technology management, at the beginning I mentioned very fragmented and very simple technological systems where water could be very cheaply managed locally and without too much spending in terms of artificial devices. In fact, even if some diminution of water resource availability is to be expected, otherwise we can very easily cope with that by investing in some more rational and industrialized operation of water supply systems, which does not necessarily mean privatization, but even though something like is going to happen, at least for the need of financing capital investments to finance structural improvements. So we are running out of time, so I cannot discuss more on this. But let me finish with some final remarks. So as I said, climate change represents an important factor of change for the equilibria that we have experienced until now. However, climate change is not the only factor affecting this change. Spatial development trends is another important factor. Hydropower, pressure towards more intense hydropower development is another factor. This is maybe somewhere some cases this might be driven also by climate change, but the most important driver here is probably the creation of an internal integrated market for electricity, which creates the case for a more intensive development, especially for large hydropower plants with big storage systems and so on. Sorry. So this last table comes from a study I made in collaboration with CIPRA, and was an attempt to discuss the likelihood of alternative adaptation measures in order to create better conditions for some concerned users, but also having the possibility to generate negative outcomes for other users. You can see we have classified measures in 4 big categories. That is how to compensate reduced availability through either through structural actions like increasing abstractions, upgrading of facilities, but also by redirecting users to other sources. The second category concerns the meeting of extra water demand which arises from new pressures due to climate change. The third concerns the improvement of water use efficiency by making the water management systems more technology intensive. And finally, the final adaptation measure can concern the reduction of pressure factors generating demand. So in each of these 4 categories, we can identify different alternatives of actions. Some of them entail more investment in infrastructure and also more higher capital costs. Some of them can instead imply institutional innovation rather than technology. So you see that the spectrum of available actions is very wide. If you look more carefully into these measures, however, you can notice that the most effective of them, and also those who are most likely to generate win-win outcomes, that is, positive outcomes for everyone, descend mostly from non-structural actions, that is, actions aimed at reallocating water rights and aiming at contrasting pressure factors at the origin. So my concluding remarks are that in the climate change is providing a very dramatic impact on alpine water resources, as we said, but this does not mean that Alps are becoming a water poor region. Alps are not turning into the Sahara. Alps will remain the Alps, and we have to get accustomed to probably to have a less generous help from the sky in terms of water availability, but this does not mean that the Alps are becoming water poor. Subalpine regions will remain water rich, even if they have to perhaps to get accustomed to an increasing level of conflict. But my point, as I said, is that managing this conflict, at least in the medium term, does not require dramatic changes in the patterns of water management. They require adaptation measures which are demanding, which are perhaps a little bit costly, which require institutional change, which requires governance, changes in the governance mechanisms, and also perhaps some the need to give up some power of the local communities in favor to larger scale decision centers, and so on. But I'm not expecting revolutions to take place, at least not in the medium long-term scenarios, which means in the next 3 or 4 decades. Thank you very much, and I'm ready to answer to your questions if you like.
Thank you very much, Professor Massarutto. It's a very interesting webinar, and I have a few questions that I will start with, starting from the one on economic impacts on tourism, and especially considering the prediction of reduction by 40% in Northern Alps and 70% in Southern Alps as a snowfall. I'm wondering, so what is the economic impact of tourism, and especially from also what is the impact by artificial snow production, which is more and more used in recent years, and especially these
yes, artificial snow production, let me start from the end of this question, has been regarded as has created some concerns about the local water balance. Sometimes it does create some temporary conflict because it uses scarce water resource in the period of the year when they are scarcer, that is winter. However, we can imagine that artificial snow production is a particular case of irrigation in the end. It's like irrigating ski resorts instead of irrigating crops, and leaving apart these very localized conflicts. Artificial snow, in my opinion, is not affecting too much the overall water cycle So the concern is not, in my opinion, caused by that. Instead, what we are experiencing as what is for me the most important concern is that the increase of the temperature makes creates the need to concentrate ski resorts and touristic demand more and more in the upper reaches of the alpine regions. And as I said, this creates a lot of pressure, not particularly for producing snow, but even for supplying water to tourists that visit these regions for very short periods, with peak demands that are very high during very short periods of the year, and so on. So as far as ski tourism is concerned, climate change is clearly representing a strong trend in this direction. However, mountain tourism is not necessarily only generated by ski. That there is a lot of mountain tourism that could also affect different kinds of activities and people. Perhaps this could also be a good news for the Alps, in the sense that much higher temperatures expected in the lowlands could mean that much more people will be will be casting for a fresher climate in summer, and will visit mountains more frequently, and so on. But for sure, climate change is a major powerful source of alteration of the actual patterns of touristic demand.
Thank you very much. We have a question from the audience. So the question is double, actually. The first is on the study on slide 11 and slide 20. So they require the source of this study, or the name of the study.
Slide one. Sorry, I want this one.
Yeah, but yes. No, page 20, slide 20 and slide 11.
Page 20, sorry.
And 11 as well.
Okay, this is a compact that I realized for CIPRA. I guess it is available from the CIPRA website. The year of this, I don't remember. It was a few years ago. I don't remember exactly when it was. It was 2011, maybe. I don't remember. I'm not sure. But if those who are interested will write an email to me, I can send the full paper if desired. But I guess you can find everything still on the CIPRA website.
Okay, so I will put you in contact. And then the question is regarding the adaptation measures. In addition to grey infrastructure and changing governance patterns, what can be the role of natural water infrastructure, such as reforestation, river basin, or wetland restorations?
Oh, I think that they are going to play a very important role, even because, okay, alpine regions are not the sole place where this is the case, but whenever demand is less concentrated, whenever we have less urban areas and more dispersed water uses to deal with, then the classical technological approach of pipelines plus centralized plants is increasingly costly and increasingly less cost effective, let me say. So, for example, there is a lot of interest, but this is not only for today, but even for the past, for natural wastewater treatment plants, for constructed wetlands used for this purpose. We ourselves made some experiments concerning the use of these techniques in most remote settlements like alpine refuges or high quota settlements and so on. This is an example. Reforestation is also going to be helpful for the sake of perhaps more for reducing the risk of dangerous floods downstream than for the sake of harvesting waters in the water table. But again, I believe that most of these techniques have an important future to play.
Thank you. So I have another question. So you said that in Italy, hydropower energy generates 15% of total electricity and 15% of renewable electricity. So what are the future projections in terms of hydropower electricity in the Italian energy mix due to considering
the Italian energy mix will not probably change too much. I think that there are two major forces in operating at the moment. The first concerns the big boost to the demand for mini hydro plants exploiting small water courses with the fluent water facilities. These have become very popular in the last 10-15 years thanks to the very generous incentives paid as for renewable energies. And this created a lot of concern among environmentalists and not only them, because of the attack to any available water stream even in the most remote places. Some regions, and I've been involved in my region's environmental impact assessment office for some time, and I can say that some regions have been more effective and more severe in trading off this request and these proposals faced to the requirements for maintaining of good ecological status and so on. But not all regions were so good in doing that. So this led to a strong development of such plants, which is probably good news for the promoters, for the developers, but not too much as far as the national energy balance is concerned. On the other hand, big pumped facilities, those that are supported by large reservoirs, where modulation of outflows is more the case, so when you can choose to drop water down in peak hours and keep water stored up in low peak moments, or you can also use pumping to pump water in the storage system once more, using other sources of energy during the night, and also use hydro peaking techniques in which one can alter the outflow freely according to the production necessities and so on. The trend about this is again, however, unfortunately very strong. This is not due to climate change probably, but rather it is due to the very high value that peak production of electricity has in the realm of a more integrated European energy market. This means that the more integrated and interconnected the system is, the more it becomes valuable to produce in peak times, not only for the surrounding regions, but also for the European market as a whole. And this means that the scarcity value of water stored in the reservoirs is becoming higher and higher. And this is one of the most important areas of concern between productive uses of water and an ecosystem, but also touristic and recreational landscape dimensions, which are affected negatively by hydropeaking. I'm not sure this belongs very much to the climate change issue, but for sure it is one of the big issues concerning alpine water management at the moment.
Thank you. Linked to this, you mentioned mini hydro, so the fact that mini hydro would be one of the solutions, and also is less water, has less water impact, but it is intermittent, so, and seasonal dependent. So how do you think to combine this with
yes, this is precisely what I say. I don't expect that mini hydro will contribute anything meaningful to the European water balance. So if one expects that we can cope with the new COP agreements signed in Paris last week with mini hydro, this is completely out of reach. Mini hydro is providing economic benefits at the macro local scale for those who manage running a plant, but I mean that I think that the trade-off between the social benefits of further expanding mini hydro and the social costs in terms of increased artificialization of alpine rivers is a negative one, and I would not support further expansion of mini hydro in general. Of course, we have to discuss on a case-by-case approach. There are also, we could also say that there are many ways to make hydropower more compatible with the environment. This is true for mini hydro, but even more for big hydro. And there is a lot of research taking place, and a lot of policy recommendations that many institutions like CIPRA have developed in order to reconcile these two important aspects.
Okay, thank you. I have a question. You mentioned the importance of public-private partnerships in water management system. Can you give us some example of PPPs in the water sector, and also how you should, how you think that PPPs would be incentivized, would be stimulated in order to create these PPPs? What is the
Okay, let me first say that PPPs and privatization in general is a sort of a taboo argument that has created a lot of concern. Many people are upset about this. We had a referendum in Italy in 2011 where the largest majority of people seemed to be very angrily badly against such possibility. I am more neutral about it. I mean, I do not see. I do not think that privatization is an obliged way to follow. But on the other hand, I recognize that in order to improve water management systems, especially those that we have met and experienced until now, thanks to the generosity of the Alps, has to change, and has to change. It means that we have to invest. Invest means to interconnect, to build more pipelines, to build more treatment facilities, and okay, we have enough water to supply to accommodate any expected demand in the next future, at least as far as public water supply and sanitation is concerned. But we need money, and we need technology, and we need more professional and industrialized water management systems. This is not to say that the public sector cannot do it. It can, but in many cases the private sector can be a helpful way to make this more feasible. Not necessarily on the technical side and on the management side, but for sure on the financial side. We need private capital markets in order to finance this kind of investment, and this need that we have to imagine professionalized water management companies and water management institutions that are able to access the financial market in order to make this possible.
Thank you very much. I have a last question, then I think we can conclude. So you said that according to Heberly, 2009, the remaining glacier surface may reduce by 50 or to 75% by 2050. So what are the impacts of this?
The impacts are, okay, in terms of the water cycle, this is not too sure. I mean, many studies seem to show that the most relevant contribution played by the Alps in terms of summer outflow is much more due to snow melting rather than to glacier melting. However, looking back to this figure, Okay, the first bad news is for alpinists and for mountaineering activity, and people like me are very concerned of the fact that we cannot do much more ice climbing in the future, and this is very bad news for us. Okay, I am joking, of course. The melting of glaciers and permafrost is probably going to affect ecosystems in higher quotas much more severely than they are affecting the overall water cycle between and the water exchange between Alps and subalpine regions. Melting of glaciers also has something to do with respect to flooding and extreme catastrophic events caused by the sudden disruption of ice falls and so on. Again, I say I'm not an hydrologist, so I would not say too much on this. But as far as I know, as far as I have been taught, at least by my colleagues in the river basin authorities, they do not feel this as a major problem in terms of hydrological cycle, but instead it is a major problem for other reasons, and especially for the dramatic alteration of the ecosystem functioning in the upper regions.
Thank you. That was very clear answer. And so I think that it's almost 5, so we can conclude here. Thank you very much, Professor Massarutto, for this presentation.
It's a pleasure for me. And please, this is for the audience. Please feel free to contact me at the email that is available on the website in case of any further request, in case of any questions you would like to pose or any discussion you would like to start.
So we will upload your presentation on our website, and also there will be a YouTube to re-listen to the webinar. So thank you very much, and thank you to all the auditors, and Merry Christmas to all of you. Bye.
Merry Christmas to you.